Reaction yield. This is the amount that you get out of a reaction compared to what you theoretically could have gotten had the chemistry been done in a perfect laboratory, in a perfect world, in a perfect universe where everything happens perfectly. Yields in real life are oftentimes a lot lower than what the paper says you could possibly get. There's always side reactions in chemistry. There's always side reactions. So the theoretical yield is the maximum possible yield that we can do on paper by doing the math that we've been doing to figure out theoretically how much product could you get from this reaction. The actual yield is what you get when you actually do the chemistry in the lab. And so in this class that would always have to be given to you, or you'd have to run it in your lab kit. But you actually have to do an experiment to get the actual yield. That cannot be guessed. And the percent yield is the actual yield divided by the theoretical yield times 100%. So, calculate the percent yield of silver bromide if 375 grams of the compound are prepared from 200 grams of magnesium bromide. Well, first we have to figure out our theoretical yield. So let's say all of my 200 grams of magnesium bromide react. I convert to moles. Then I see my stoichiometric ratio is 2 to 1. I produce 2 moles of silver bromide for every 1 mole of magnesium bromide consumed. Let's make sure it's balanced. 1 magnesium, 2 bromines, 2 bromines, 2 silver, 2 nitrates, 2 nitrates. It is balanced. So I could make 408 grams of silver bromide in theory. But what I actually got was 375 grams. I did not get the 408 grams that the theory says I could get. So to get the percent yield, I take my actual yield, 375 grams, divided by my theoretical yield, 408 grams, times 100% to get 91.91%. Calculate the percent yield of aluminum oxide if 125 grams of aluminum yield 100 grams of aluminum oxide. This is an example of a thermite reaction. The more famous one is iron metal with, or actually aluminum metal with iron oxide. And then it ignites, and it's one of the hottest reactions that occurs. It's a couple thousand degrees in temperature when it reacts. And then when you're done, you have aluminum oxide and molten iron. This is basically another thermite reaction, except you're going to end with molten chromium. But we run our theoretical yield. I have 125 grams of aluminum. I use my trusty periodic table to find the molar mass to convert to moles. And it is a 1-to-2 ratio. I will produce 1 mole of aluminum oxide for every 2 moles of aluminum consumed. Convert back to grams. In theory, I could make 236.3 grams of aluminum oxide. But I don't. I only get 100 grams. So the percent yield is 100 grams, the actual yield, divided by the 236.3 grams I got on paper for my theoretical yield, times 100%, and that gives me 42.32%. And that's a pretty low reaction yield, so at that point a chemist would do what we call optimization. You play with your solvents, your temperatures, and your conditions, trying to bring that percent yield up to get more product every time you run the reaction. And that is the end of Chapter 9.